Hello students, in our previous class we learned about commutative property, associative property, distributive property. Okay, that is AB is not equals to BA when A and B are two matrices where multiplication is possible. Okay, so AB is not equals to BA imply matrix multiplication is not commutative. Again, AB into C is equals to A into BC, where A, B, C are three matrices where multiplications are possible. So, AB into C is equals to A into BC. So, these things imply matrix multiplication is associative. Then, A into B plus C is equals to AB plus AC. That is, matrix multiplication is distributive with respect to addition. This distribution is known as left distribution. Okay. Then we can also write B plus C whole into A is equals to BA plus CA. This is known as right distribution with respect to addition. Okay. Again, if A is a square matrix, then we can write A square is equals to A into A. A cube is equals to A square into A, and so on. That means A to the power 4 is equals to A cube into A. Okay. So these are the main properties of matrix multiplication, addition, etc. Okay. So depending upon these properties, we have to solve some problems. Okay. That is why here we choose this problem. Here A and B are two matrices where A plus B is equals to this square matrix, and 2A minus B is also another square matrix. So these matrices has order 3 by 3, and this matrix also has order 3 by 3. That is, these two matrices has equal rows and equal number of columns. Okay, that is why they are square matrix. So these two results, that means A plus 2B is equals to this square matrix and 2A minus B is equals to this square matrix, represents that A and B will be square matrices of order 3. Okay. So let us study how we can find matrix A and matrix B. Given A plus 2B is equals to, along first column 1, 6, minus 5, along second column 2, minus 3, 3, along third column 0, 3, 1, and 2A minus B is equals to, along first column 2, 2, 0, along second column minus 1, 1, along third column 5, 6, 2. This is equation number 1 and this is equation number 2. To make these b's are equal, we have to multiply this equation 2 by 2. Now, relation 2 becomes 4A minus 2B is equals to, when we multiply this matrix by 2, then we have to multiply all the elements of this matrix by 2. Already we know scalar multiplication of a matrix. By that way, we have to multiply all the elements of this matrix by 2. So after multiplication, we have along first column 4, 4, 0, along second column minus 2, 2, along third column 10, 6, sorry, 10, 12, 4. Again, from 1, we get a plus 2b is equals to 1, 6 minus 5, 2 minus 3, 3, 0, 3, 1. Adding, cancelling this minus 2b plus 2b, we get 4a plus a, that is 5a is equals to, we can also add these two matrices as their orders are same, and we know how we can add two or more matrices. When we have to add two or more matrices, then their orders must be same, and we have to add, or we can add same positional elements. Okay, like this way: 4 plus 1, 5, 4 plus 6, 10, 0 minus 5 will give minus 5, minus 2 plus 2 will give 0, minus 2 minus 3 will give minus 5, 2 plus 3 will give 5, 10 plus 0 will give 10, 12 plus 3 will give 15, and 4 plus 1 will give 5. Okay. This implies 5a is equals to, in this matrix all the elements are the multiple of 5, that is why we can take 5 as the common factor. After taking 5 as the common factor, the resulting matrix becomes 1, 2, minus 1, 0, minus 1, 1, 2, 3, 1. Cancelling these 5 from both sides, we get a is equals to 1, 2, minus 1, 0, minus 1, 1, 2, 3, 1. So matrix A becomes, along first column 1, 2, minus 1, along second column 0, minus 1, 1, along third column 2, 3, 1. So A becomes this matrix. Now to find B, we have to put this value of matrix A in equation 1. Putting A equals to 1, 2, minus 1, 0, minus 1, 1, 2, 3, 1 in relation 1, we get 1, 2, minus 1, 0, minus 1, 1, 2, 3, 1 plus 2b is equals to 1, 6, minus 5, 2, minus 3, 3, 0, 3, 1. This implied 2b is equals to 1, 6, minus 5, 2, minus 3, 3, 0, 3, 1 minus this equals to 1, 2, minus 1, 0, minus 1, 1, 2, 3, 1. This implied 2b is equals to similar as addition. We have to subtract between same positional elements. Okay. So 1 minus 1 will give 0. 6 minus 2 will give 4. Minus 5 minus of minus 1, that is minus 5 plus 1 will give minus 4. 2 minus 0 equals to 2. Minus 3 minus of minus 1, that is minus 3 plus 1 will give minus 2. 3 minus 1 will give 2. 0 minus 2 will give minus 2. 3 minus 3 will give 0. 1 minus 1 will give 0. Two is the common factor among all the elements. So taking 2 as the common from both sides, we get 2 into 0, 2 minus 2, 1 minus 1, 1 minus 1, 0, 0. Cancelling these two from both sides, we get b is equals to 0, 2 minus 2, 1 minus 1, 1 minus 1, 0, 0. So this is the way by which we can find these two unknown matrices, okay, when these relations are given. Okay. Here we choose a problem. In this problem, f of x is equals to x square minus 5x plus 6. Okay. And matrix A is equals to, along first column 2, 2, 1, along second column 0, 1, minus 1, along third column 1, 3, 0. We have to show f of A is equals to this matrix. Okay. That means to find f of A, we have to satisfy this relation, this polynomial relation by matrix A. Okay. So let us study how we can find this matrix f of A. Solution. Here f of x is equals to x square minus 5x plus 6 and matrix A is equals to, along first column 2, 2, 1, along second column 0, 1, minus 1, along third column 1, 3, 0. Now f of A is equals to a square minus 5a plus 6i, where I is the identity matrix of order 3 by 3, because order of matrix A is 3 by 3. That is why when we want to replace this variable x by this matrix A, then we have to write f of A is equals to a square minus 5a plus 6i, because these terms will give a matrix, and to get a matrix here, that means in place of 6 we have to multiply this number 6 by the identity matrix of order 3 by 3. Okay. That is why first of all we have to find a square. A square means A into A, that is matrix A into matrix A, by this relation. Two, 2, 1. 0, 1, minus 1, 1, 3, 0 into 2, 2, 1, 0, 1, minus 1, 1, 3, 0. Already we know when we have to multiply between two matrices, then we have to follow row by column method. Okay, that means this first row will be multiplied with this first column, and this will give the first element of this new matrix. 2 to the 4 plus 0 into 2, 0 plus 1 into 1 will give 1. First row, second column. 2 into 0, 0. 0 into 1, 0. 1 into minus 1 will give minus 1. First row, third column. First row, third column. 2 into 1, 2. 0 into 3, 0. 1 into 0 will give 0. Second row by first column will give uh, element of second row first column of this new matrix. 2 to the 4 plus 1 into 2 will give 2. 3 into 1 will give 3. Second row, second column. 2 into 0, 0. 1 into 1 will give 1. 3 into minus 1 will give minus 3. Second row, third column. 2 into 1, 2. 1 into 3 will give 3. 3 into 0 will give 0. Third row by first column. 2 into 1, 2. Minus 1 into 2 will give minus 2. 0 into 1 will give 0. Third row, second column. 1 into 0, 0. Minus 1 into plus 1 will give minus 1. 0 into minus 1 will give 0. Third row, third column. 1 into 1 will give 1. Minus 1 into 3 will give minus 3. 0 into 0 will give 0. So 4 plus 1, 5, minus 1, 2. 9 minus 2, 5. 0 minus 1 minus 2. So a square becomes 590 minus 1 to minus 1, 2 5 minus 2, 5a. That means multiplication of this matrix A by 5. 5 into 2, 10, 10, 5. 0, 5 minus 5. 5, 15, 0. 6i, that is 6 into identity matrix of order 3. 1 0 0 0 1 0 0 0 1. 6 0 0 0 6 0 0 0 6. Now we have to put these values in this relation f of a. Okay. F of a is equals to a square. A square means this matrix 5 9 0 minus 1 minus 2 minus 1 2 5 minus 2 minus 5a. 5a means 10, 10, 5. 0, 5 minus 5. 5, 15, 0. Minus 6 and plus 6i. 6i means 6, 0, 0. 0, 6, 0. 0, 0, 6. 5 minus 10 plus 6, that is 5 plus 6, 11, 11 minus 10 will give 1. 9 minus 10, that is minus 1. Minus 1 plus 0 will give minus 1. 0 minus 5, that is minus 5 plus 0 will give minus 5. Along second column, minus 1 minus 0 plus 0, that is minus 1. Minus 2 minus 5, that is minus 7. Minus 7 plus 6 will give minus 1. Minus 1 plus 5 will give plus 4. Plus 4 plus 0 will give 4. 2 minus 5, that is minus 3. Minus 3 plus 0 will give minus 3. 5 minus 15, that is minus 10. Minus 10 plus 0 will give minus 10. Minus 2 minus 0, that is minus 2. Minus 2 plus 6 will give plus 4. So, f of a is equals to, along first column 1 minus 1 minus 5, along second column minus 1 minus 1 4, along third column minus 3 minus 10 4, which is same with this matrix. Okay, thus the proof arises. Okay, so this is the way by which we can prove f of a is equals to this matrix. Okay, so when a polynomial is given, then to replace that variable by a matrix, then always we have to write an identity matrix with the same order with the constant in the product form. Okay, like this way. That means f of x is equals to x square minus 5x plus 6 imply f of a is equals to a square minus 5a plus 6i, where I is a matrix, I is the square matrix, I is the identity matrix of order 3 by 3. Okay, in our next class we will learn a special property of mathematics, or you can say the operation known as transpose, and some application of this transpose of matrices in some numericals. Okay.